Okay, welcome back. And now what we're going to do is we're going to do an example of using the problem strategy that we did in the last video. So what we have is the question or the problem says evaluate the limit as x approaches 0. So a is equal to 0 here of this function using a table. So sine x over x. Now here's the problem. Sine, as we know, bounces back and forth between 1 and negative 1. X can be anything. Okay, so the problem is we know that as this fraction, as x goes to infinity, we know that this thing is going towards 0, right? Because as this is going bigger, 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 the biggest that this will be is 1. So we know that this is going to overpower it and it's going to end up going towards 0. But we're not going towards infinity. We're going towards 0. Well, what happens? Well, x sine of 0 is 0, and 0, so we get 0 over 0, which is indeterminate form. So it doesn't give us anything. So we don't know. So what do? We're going to use a table to see what's going on. Okay? So what I'm going to do is I'm going to write down the values that I get from the calculator. Okay? Again, do this on your own for understanding. So I'm just going to write in the values. I'm not going to write in all the values, but I'm going to write enough. Okay, now over here, okay, so notice when we look at both of these tables, okay, notice that from negative 0.1 to positive 0.1, these are the same. These are the same, these are the same, these are the same. So it's symmetric, right? So it's symmetric about the y-axis. Also, look where these two are going. They're going towards what value are they tending towards? 1. So we would state that the limit as x approaches 0 of sine x over x is equal to 1. And we can verify that using the graphing calculator and using a graph. Okay? We're also going to show this later on algebraically when we get to using limits and we get to the precise definition of a limit. We will, and then the properties of limits will show that this is indeed the limit of sine x over x. Okay? Have a great day.